In this lesson, we want to be able to say that I can identify perpendicular lines. First thing, if we want to be able to identify what perpendicular lines are, we need to know what these words actually mean. So perpendicular is whenever two either lines, line segments, or rays form a right angle. So we could have two rays go and pass each other. As long as they form a 90-degree angle, a right angle, then they are perpendicular. Two objects are perpendicular if they make a 90-degree angle. Perpendicular lines, it's just a little bit more exact. It's not talking about rays, it's talking specifically about lines themselves. So if we have two lines that cross and they are perpendicular, then these two lines are going to form a 90-degree angle. 90 degrees. That is what perpendicular line means. With just perpendicular, two objects perpendicular. It can be two planes perpendicular. It can be a line and a ray. It does not matter whether you choose the same object. Perpendicular lines, they form 90-degree angles. So that is what the word perpendicular means. Let's look at a few examples of how to actually use this. So example, find the value of x and y so that line FC and line BD are perpendicular. Okay, so it's telling us we want line F to C and line B to D. So this line here, F to C and B to D, we want these two lines to be perpendicular to each other. So in other words, we need this to be a 90-degree angle. Then we need this other angle over here, the sum of those two angles, to be 90 degrees. If they're perpendicular, it's going to be 90 degrees. So what we're going to end up doing is we're going to look at the measure of angle BAC. The measure of angle BAC, because we want these to be perpendicular, will have to be 90 degrees. Well, BAC, we're given an equation. We're given that is 8x plus 2. That is what BAC is, the angle that is given to us right there. So all we had to do, if we want to find the value of x, all we have to do is just a little bit of algebra and solve for the value of x. So let's minus by 2 on both sides so that we end up with 8x equals to 88. Divide by 8, right, our algebra skills, so that x is equal to 11. We have found the value of x. Excellent, right? Next thing we want to do is we need to find the value of y. Well, y is stuck over here in all of this stuff. Maybe later. It's stuck over here in all of this stuff. We also have some x's stuck in there. But now we know the value of x. So what we're going to do is we are going to set up another equation. And how we're going to set it up is we have two angles over here. These two angles form a right angle whenever you put them together. So what we're going to be doing, remember the angle addition postulate, add the two angles up, that equals the bigger angle. The bigger angle is 90 degrees, so we are going to just go for y minus by 2x, that's the first angle. Add the second angle, that's 6x minus 2y, equals to 90 degrees. We are told that we are wanting these two lines to be perpendicular, so that must be a 90-degree angle. From here, gather like terms. We have 4y and we have negative 2y. Put those together. So that's going to end up to be 2y. We have negative 2x and 6x. So this would end up to be positive 4x. And that is going to be equal to 90 degrees. That looks a whole lot nicer. We have all the x's together, all the y's together. What we need to do now is just substitute for the value of x. We know x is 11. So let's take this 11 and put it in the value of x. So this would be 2y plus 4 times 11 equals 90 degrees. Well, 4 times 11 is 44. This would be 2y plus 44 equals to 90 degrees. Minus by 44, so 2y is equal to, 90 minus 44. Subtract, this would end up to be an 8. This would be 10. 10 minus by 4 is 6. 8 minus by 4 is 4. So this would be 46. Get y by itself, so we divide by 2. Divide by 2, so 46 divided by 2 is going to end up to be 23. The value of y? 23. We found the value of x, and we found the value of y. That is what the question's asking. Find the value of x and y so that these two lines are perpendicular. Well, if x is 11 and y is 23, then both those angles are equal to 90 degrees. We could find each and every individual angle here. We could find the angle of FAE. We could find the angle of EAD, but it doesn't ask that. If you wanted to find those, we just substitute the values into each of those expressions. Okay, so let's look at this figure. There are some things with these figures that you can assume, and there are some things that you cannot assume. So what can be assumed about this figure? Coplanar. We can assume that all of these are on the same plane. That's simple enough. We're going to assume that all these points are on the same plane. Collinear. We are going to assume if it's a straight line. If we can notice that it's a straight line, we can assume that it's collinear, that they lie on the same line. Remember, collinear means that they lie on the same line. So, for example, we can say that point E, P, and B, we can assume that those are collinear because they are on the same line. Intersecting. If two lines cross, they intersect. We can assume that P, let me use a different color, P is a point of intersection. We can assume that line AD intersects line BE. Okay, so we can assume this line AD intersects line BE. We can assume that. Between, we can assume that P is between EB. We can assume that P is between AD. Remember, between means that they are opposite rays and they connect at that point. So we can assume that P is between E and B. We could also assume that's between A and D. Those are things that we can assume because those are straight lines. Interior. We can assume certain points are inside some of the angles. We can assume that. For instance, we can assume that point C is interior of angle. So point C is interior to angle BPD. That's one example. There's other examples of interior points. We could have point D. Point D is interior to angle EPC. We could have point A is between angle BPE, right? That's a line, but it's still an angle. This would be 180 degrees. So A is between. Another thing we can assume, adjacent angles. We can assume that two angles are adjacent. Remember, in our last video, we talked about adjacent angles. Adjacent angles share one side and one vertex. So, for example, we can say that angle 1 and angle 2 are adjacent. We can assume that. Now let's talk about a few things that we cannot assume. Oh, wait, before we get there, there's a few more things. A few more things that we can assume. Linear pairs. We can assume linear pairs because if we have a straight line, we know that two angles, when they get together and they form a straight line, we know they're linear pairs. So, for example, we can assume that angle, let's do angle EPA and angle APB are linear pairs. They form the straight line with this extra little angle right there. They form a straight line. We can assume that because EPB, line EB, is a straight line, okay, because that is linear. So that's why we can assume that. Supplementary. We can assume supplementary. For the same reason we can assume linear pair. If it is adjacent, then we can assume that it could be supplementary because it's also linear pair. Linear pairs are always supplementary. Supplementary is not always linear pairs. So we could assume supplementary, especially in this example, with the same angle. What can we not assume? We cannot assume that angles are perpendicular. We cannot assume that because we do not necessarily know what this angle is. It doesn't tell us. So we cannot assume perpendicular lines. We can assume straight lines, but we cannot assume perpendicular lines. We cannot assume that angles are congruent. So for example, we cannot assume that angle 1 is congruent to angle 2. We cannot do that. Not allowed. Okay, so we cannot assume congruence. They have to tell us congruence. We have to be told that it's perpendicular. Congruent segments. We cannot assume that segments are congruent. We cannot assume that segment EP is congruent with PB. I'll get it eventually. We cannot assume that segments are congruent. So we cannot assume congruence. We have to show congruence. Part of the reason. These pictures that we do are not 100% accurate. They're more of a guideline to give you an idea of what it could look like. It's not an accurate picture. Yes, it might be accurate, but we cannot assume that it's 100% accurate. It's just a representation of what's going on. So for all we know, this ray, P to A, could actually be more like this, where A is over here. But we cannot assume that, okay? So we have to be very, very careful about the things we can assume. So congruence, you can never assume. Perpendicular, you cannot assume. Let's look at this example. Determine whether each statement can be assumed from the figure. Measure AGC. Measure A to G to C. So this is our angle right here. Can we assume that that's 90 degrees? Well, based off of information given to us, we can, because we have information. Notice we are given that this angle is perpendicular. If that angle is perpendicular, and also these two angles, BGC and CGA, since those are linear pairs, we can assume linear pairs, right? These two angles, this angle right here, is a linear pair or supplementary to this angle right here. Since they're a linear pair, then we can assume that this would also be 90 because we're told that the other one's 90. So this would be yes, and give a reason. Why? We can say angle AGC and angle CGD are linear pairs. And measure of angle CGD equals 90 degrees. We know that. Because they give us that, we can assume that the other one's 90 degrees. Can we assume that angle AGB and BGC are complementary? So let's look at that. So we have angle AGB, and BGC. Oh, let me choose a different color. BGC. Can we assume that these two angles are complementary. Well, because we can assume that this is 90 degrees, we can say yes. Since we know that the measure of angle AGC is 90, those two would be complementary. So yes, let's give a reason. Measure angle AGC is, actually let's put it as an equals, is 90 degrees. The sum of the two angles add to 90, so it's complementary. Can we assume that line segment, let me erase that line segment AG and GD, can we assume that these two line segments are congruent? No, we don't know anything about the length of those segments. So this is no. We do not know anything about the length of the segments, so we could write that down. But for sake of time, I'm not going to. Can we assume that, let me go ahead and erase that, BGC, let me write this down, B to G to C, can we assume that this angle is congruent to AGF? AGF. So can we assume that this angle is the same as this angle? No, we cannot. Yes, we are given that FGE, this angle and this angle are congruent. We don't necessarily know anything about the other two angles. So this one would be another no. We cannot assume that.